Nutrition is eating food to connect the want or necessity.
Yes, some people will say that. Yes, nutrition means eating food to gain energy so that we can do our functions well, so that our body can function well. Okay, like eating food, and when we eat food, our body absorbs the nutrients from that food before the food is digested. Okay, it absorbs the nutrients and then it is sent to all parts of our body, and from that food we get nutritions. Okay, in the form of vitamins and all. In that food we get nutrition. Now, Sushila and Ram were playing outside their home. Their mother called them for having food. Children were busy playing. They didn't want to leave the game. Sushila asked her mother, Ma, why do we eat food? Why? Um, what is its need? Why can't we always play? Mother laughed at her words. She said, do you feel hungry? If yes, then eating food is a solution to stop hunger. Let us eat food and I will tell you about nutrition. Okay? So, a girl was playing and her mother, like, imagine if, like, sometime we are playing and our parents' mother calls us to eat food, and we think, that, oh, we have to stop what we are doing now and go eat food. So she's asking that, why do we have to eat food? Why can't we just keep playing? Why can't we just keep doing what we are doing? Um, her mother says that eating food, if you're feeling hungry, it is important to eat food. Okay, and she's going to tell her about nutrition. Nutrition means eating healthy food is very necessary. Both animals and plants take nutrition in one form or another. What is the difference between plants and animals? What are the types of nourishment? What do you mean by digestion process? We will study these topics in this chapter. And that's a lot. An introduction. Okay, so let's take a look at the first type of topic, that is various types of nourishment. Okay, now food or nutrition is necessary for every living being, both animals and plants. Nourishment items are essential for the physical growth, structure, physical structure, growth, health, and maintenance of non-working or weak parts of living beings. Living beings get energy required for the essential movement from food. The process and technique of eating food and the use of its energy is known as nourishment. Now, what is nourishment? See, there are various types, okay, or various ways in which, um, like an organism eats and obtains energy. Okay, there are various ways in which an organism eats and obtains energy. So this is dependent on that. Okay, like nourishment is how they like obtain energy and how they utilize this energy in their body. Okay, that is basically nourishment. Now, nourishment is of two types in living beings, which include two modes. One is known as autotrophic mode of nourishment or heterotrophic mode. Okay, so first we'll see what is autotrophic mode. Now, this is that method of nourishment where living beings prepare their own food. These plants prepare their food with the help of water, carbon dioxide, and minerals. Thus, they are known as autotrophic. Okay, they prepare their own food. Okay, they're good at cooking and they prepare their own food. Okay, not really. They are made in that way. They have the chlorophyll present. They have all the resources to prepare their own food. Whereas there is another type of plants known as heterotrophs, okay, or heterotrophic plants. Animals and other living beings make their food with the help of food synthesized by plants. They are known as heterotrophs. Okay, they're dependent on other organisms, okay, other plants or animals for food. Okay, they're dependent on other organisms for food. They are known as heterotrophs. Heterotrophic. Many animals are heterotrophic because they cannot make their own food, but they eat plants as the food, or they eat other animals or other organisms as food. Humans are autotrophic because we make our own food, okay? Because we make our own food. Then there is the process of photosynthesis. What is photosynthesis? Photosynthesis is a process that takes place in plants by which they prepare their food. Okay, by which they prepare their food. Leaves are the kitchen of the plants. Plants, they prepare their food in the leaves. Now, how in the leaves? We have the definition. The process of preparing food in plants is known as photosynthesis. Therefore, all the raw materials are supplied to the leaves. These raw materials are absorbed by water and minerals by the roots of the plants present in soil. Okay, so there is water. Okay, that is and like all the things that is necessary, they're absorbed by the roots. We know this, right? It is absorbed by the roots of the plant. Okay. These absorb water and minerals are sent to leaves by stem. When the water absorbs, when this root absorbs minerals and water from the ground, the roots are connected to the stem. Okay, the roots are connected to the stem. So it goes to the stem. From the stem, it travels and is taken to the leaves. There are small holes present in the layer of leaves. These holes help leaves in getting the carbon dioxide present in air. These holes are covered by epidermis cells and they are known as pores. Okay, they are known as pores. These are the pores. The entire structure is known as pores. These pores in the leaves, they close and open. They close and open. When they close and open, the breathing process, the gaseous exchange in plants takes place. Okay, plants take in carbon dioxide and give out oxygen. Okay, during the closing and opening of pores. Now, leaves are a green color. Okay, why? Is because a green color pigment is present in the leaves, which is called chlorophyll. Leaves are of green color due to the presence of chlorophyll. Chlorophyll helps leaves in collecting energy from the sunlight. This energy is used for synthesizing the food. By food synthesis, it is the meaning of synthesizing food. We mean that the use of stored energy, water and CO2, are used to prepare food. Okay, the stored energy, because from the energy, the chlorophyll helps collect energy. Okay, and then that energy is stored in the plant. Okay, then with that energy, or like the sunlight, you usually say sunlight that is used. Plants use sunlight to prepare. If you've heard this, plants use sunlight to prepare their own food. Why is it said that they use sunlight? Because they obtain an energy from sunlight. Okay, and then they use chlorophyll. Okay, and water. Then they use carbon dioxide and water to prepare their food. Okay, since this process is done in the presence of sunlight, it is called photosynthesis, known as photosynthesis, because synthesis is done in the presence of sunlight, so we call it photosynthesis. Therefore, in the process of photosynthesis, chlorophyll present in the leaf synthesizes water and carbon dioxide to prepare food. This process is presented in the form of the following equation. What is the equation of synthesis in plants? Carbon dioxide plus water, CO2 plus water plus chlorophyll in the presence of sunlight gives carbohydrate plus oxygen. Carbohydrate in the form of or glucose, that is the food of the plants, and oxygen. Okay, this is the equation of synthesis or photosynthesis in plants. Okay, any doubt in photosynthesis, in the process of photosynthesis in autotrophic, heterotrophic modes of nutrition? Let's move forward there. This process helps in releasing oxygen. Carbohydrates are changed to starch in this process. For the process of synthesis, we need chlorophyll, sunlight, water, and carbon dioxide. Leaves collect sun energy and prepare food for the plants. The life of all living beings is directly and indirectly dependent on the stored food. Okay, because a lot of plants we eat in the form of vegetables. A lot of animals eat these plants as vegetables. Okay, some plants, other plants are also dependent on them for food. Okay, so on this like food of the plants, a lot of living beings are dependent on. Okay, therefore, sun is the prime source of energy for all living beings. Okay, because plants obtain energy from sun and then they synthesize. Okay, then they synthesize the food. So, sun is the prime source of energy. Oxygen gas, which is required for every living being, is released in the process of photosynthesis. So, this is also the reason why it is said that to reduce pollution, to save the environment, plant more trees. Okay, plant more trees. Why? Is because there exists this that when we plant more trees, they will release more oxygen. Okay, and it will give us more oxygen. Like the amount of the oxygen in the air will increase by planting more trees. That is also why when we go to forest or in areas, okay, when you breathe, you will feel fresh air, a lot of fresh air. You will be able to breathe and inhale and exhale, right? And you breathing fresh air. Why fresh air? Why do you feel fresh air? Because the trees are releasing a lot of oxygen in that area. Because a lot of trees are there. Okay. Then it is impossible to imagine a life on Earth without photosynthesis. Then chlorophyll is present in all colors of leaves. Chlorophyll is found in all types of leaves like green, red, yellow, brown, etc. These colors cover the chlorophyll of the leaves, but these leaves are involved in the process of photosynthesis. So chlorophyll is also there in red, yellow, and brown leaves. Okay, it's still present even though they are not colored, but they still have chlorophyll in them, and with it um they produce their food. Do you know that not only leaves but green parts of plants like branches and stem also help in the process of photosynthesis? Desert plants take shape of thorns for the objective of less evaporation. Green stem of these plants prepare food by photosynthesis. So those plants, those desert, if you've seen the cactus, something like this, thorned, right? So this cactus doesn't have leaves. So how will it prepare its food if the cactus does not have leaves? That time, the food is prepared in the stem of the cactus. The food is prepared in the stem of the cactus, and then it goes to the entire cactus, okay? The body of the cactus. Green stem of these plants prepare food, but the process is same. Photosynthesis, in the presence of sunlight, with the help of carbon dioxide and water, they prepare they do photosynthesis and prepare their food. Other than these, algae and weeds, they also prepare food by process of photosynthesis. Imagine algae. Algae doesn't have a stem, okay, or leaves, but the body of algae, okay, and weeds, they the photosynthesis, the process of preparation of food goes inside the body. Okay. Yeah. Okay. Now, we are going to stop here for science. Tomorrow we will do 1.1, and we will see what are the other modes of nourishment, or the other modes by which organisms eat food. Okay. So you have like 2 minutes break only. Okay. So please go and come back. Tap out and come back. Only 2 minutes. Okay, let's begin. Please share your videos. Please share your videos. We are going to start now. Hi, Nathaniel and Joshua. Good morning.
Good morning, ma'am.
Good morning, ma'am.
Good morning. Okay. Now, we are going to do the question about the racers. Okay. Now, two racers, they take part in a race. Okay. And A starts running. A two racers race. A starts running. Their names are A and B. Okay. When racer B has gone 100 meters ahead, when B has gone 100 meters ahead, if racer A takes 6 minutes, if A takes 10 running 1 kilometer, then in how much time? In how much time will A cross B? A cross the racer B. Understood the question. Both the racers A and B are going to race, but B starts first, and A starts after B has run 1000 meters. Anna, Abraham, Emma, Nathaniel, turn on your videos. Abraham and Emma, turn on your videos.
Ma'am, I'm in a car, so my internet is kind of bad.
Okay. Okay. Now, this A started later when we covered 100 meters. Okay. Now, A takes 6 minutes to do 1 kilometer and B takes 10 minutes to do 1 kilometer. After how much time will A cross B? After how much time will A cross B? That is our question. Okay. Now, what we will do is we know that A, we know that A
Ma'am,
run. Yes, Abraham.
ma'am, just one thing I have to tell you, ma'am. The question in the book, they say two races. A starts running when B starts has gone 100 kilometers. They tell us A 12 takes. I'm not sure what the number, but they say A takes 12 minutes, but they don't see the time that B takes.
Okay, they are not telling you the time that B takes. Okay. Then Abraham, I can solve the this question with you, and then I can solve that question with you. Both. Okay. I can do both the questions with you. Okay. Now, so 6 minutes he's running. In like 6 minutes he's taking to run 1 kilometer. Then in 10 minutes, we'll find out 10 minutes for A. 10 minutes. How much will A run in 10 minutes? 1 into 10, 10 kilometer divided by 6 minutes. Okay. This is 10 kilometer divided by 6 minutes. 10 minutes, 1 into 10 divided by 6 minutes. That is how much he is going to um, run. How many kilometers is he going to run in 10 minutes? So we have pi by 3 kilometer. Okay, 5 by 3 kilometer. 10 minutes he will run 5 by 3. Okay, now we will find out how much A runs more than B in 10 minutes. Now I have A's in 10 minutes and B's. Okay, so how much A runs more than racer B? Okay, so for that, A runs 5 by 3 minus 1. Solve it and tell me how many kilometer more racer A will run than racer B in 10 minutes.
Ma'am, why are we doing 5 by 3 minus 1?
Why are we doing 5 by 3 minus 1? Because we are finding like 10 minutes of A we have found out like how much A is going to run in 10 minutes. Okay. Now we are finding out A runs how much more than B in 10 minutes. A we've taken the whole, 1 we've taken the whole, and we're subtracting from the A's 10 minutes.
Ma'am, can you just repeat because I'm not understanding?
Not understanding. See, A runs 6 minutes in 1 kilometer. 6 minutes. Yes, A runs 6 minutes in 1 kilometer. Now, but B is running 10 minutes. So to check out A's, okay, this is the difference. Okay. So we first calculated how much distance will A run if A runs with 10 kilometer, like 10 minutes speed. 10 minutes, 1 kilometer, 10 minutes. If A runs like that, how much distance A will cover? Okay. Then that is how much more than B is covering in 10 minutes. That is how much more than B is covering in 10 minutes. That is why you subtract 1 from the distance that A is covering in 10 minutes.
Because B is covering one whole.
Yes, B we've considered as B is covering one whole.
Ma'am, is it 2 upon 3?
Is it 2 upon 3? Yes, it is 2 upon 3. A is running 2 upon 3 kilometer more than B in 10 minutes. Okay, A is running 2 upon 3 kilometer more than B in 10 minutes. Okay. Now, because we have to do the conversion also, We can write it down like this. 2 by 3 converting it to meter
Ma'am, you're breaking
divided by 1000,
with your network.
2 by 3 meter. Are you able to hear me?
Yes, ma'am.
Okay.
Yes, ma'am, we can hear you, but your voice is breaking up.
Yes, ma'am. Your voice is breaking.
Okay. I think I'm having a network issue. Okay. Okay. Now, for B, or like no, the question says that when B has gone, A starts running. When B has gone 100 meters, how many? When B has gone 100 meters. Okay. So now we have to find out that if B has gone like 100 meters and then A starts running, in relation to that, we have to calculate. In relation to that, we have to calculate. So we have to find out in how many minutes, A will run 100 meters so that he crosses B. Okay, try to understand this. We have to calculate in 100 meters how after like 100 meters if he's run, how much time is gonna take to run him 100 meters to cross B. Okay, so A runs 100 meter in, we'll form an equation. Okay, we'll form an equation. We have 10 minutes. 3 by 2 we are going to take. Okay, but we are going to do its reciprocal. We are going to do its reciprocal. Okay, because we have to calculate for 100 meter. So 10 multiplied by 3 multiplied by 100 meter divided by 2 into 1000, where 1000 is coming from this equation. Okay, from this equation, kilometer to meter conversion. But we are only to find out for 100 meters. So 100 is coming from the question, the 100 meter. And 10 is the time, 10 minutes. Okay, because this is more to do with the speed of B. Okay, because he's like to catch up with B. Okay, and B is taking 10 minutes. Okay, A is faster, A is taking only 6 minutes. And B has already run 100 meter when A starts. So we have to do A in relation with 10 minutes and that 100 meter which B has already run. Okay, so solve this. 10 into 3 into 100 divided by 2 multiplied by 1000.
Ma'am, I'm getting 3 upon 2.
3.2?
Yes, ma'am. Ma'am,
Are you getting? Yes, Abraham.
why did we put 3 on top?
Why did we put 3 on top? Because Abraham, we like did a reciprocal of 3 and 2 because we are finding it for 100 meter.
And
And then we solve it.
okay. And that's why 3 went on top.
That's why we are putting 3 on top because we are like finding for 10 minutes and 100 kilometer, 100 meter.
3 on top. Okay, ma'am. But I'm not understanding why we perform the reciprocal.
Where we perform the reciprocal, it's like just to adjust all the values in the question.
Okay, ma'am. Ma'am, then I'm also getting 1.5.
1.5. 1.5 for 1.5 minutes is the right answer.
So, ma'am, A will run 1.5 meters before catching up with, before crossing B.
B, yes. A will run 1.5 minutes before crossing B.
B will run for 1.5 minutes before crossing B. Okay, ma'am.
Yes, yes. When B has already done 100 meters, A will run 1.5 minute and then he'll cross B.
Ma'am,
Yes.
but you are not covered like in the actual question, ma'am. Like in the book, it says racer P and Q take part in a competitive. Racer Q starts running
Mm-hmm.
when P has covered 1 kilometer. So Q takes 12 minutes to cover. How much time will it take Q to cross? It doesn't say
Mm-hmm.
cross, and it also doesn't say how much time does P take to cross 1 kilometer. Also,
Okay. Mm-hmm. Okay. We'll have to like assume that we'll have to assume the values as X and find it out. Fifteen minutes. And I think you will need relative speed also. In that question, you'll have to use relative speed to find it out. Relative speed of P to Q. We can try it out right now. Hope my voice is better now.
ma'am, also we have to do the length of the train. Because he's
Length
finding
of the train.
the speed of a train.
Speed of a train. Okay. Let's check out the racer and then we'll check out the speed of it. Okay. Now, what the question says, P and Q take part in a competition. Racer Q starts running when P has covered 1 kilometer.
Ma'am,
Yes.
I
Yes.
I can't see anything on the screen, ma'am.
Were you writing it down still?
Yes, ma'am.
Have you finished writing this question or do you need more time to write it down?
I finished writing the question, ma'am.
Finish writing the question. Okay. Then I'm going to write on the screen. So it's empty, blank.
Okay, ma'am.
Now, racer Q starts running when P has covered 1 kilometer. And Q takes 12 kilometer, 12 minutes, 12 minutes to cover 1 kilometer. How much time will Q take to cross? P, I think so. Time Q. Cross. Okay. Now, people assume that the speed of P is 1000 meter divided by x minutes. So 1000 divided by x meter per minute. Okay. And we assume that the speed of Q is given, so we don't need to assume it. Is 1000 divided by 12 meter per minute. Okay. Now we will calculate the relative speed of Q to P. Okay. Relative speed of Q to P. Okay. Why? Because we know the speed of Q is given to me. Okay. So because Q starts running when P has covered 1 kilometer, Q is behind P. Okay. And the relative speeds of Q and P will be the difference between their speeds. Okay. And will the difference, because they're all both going in the same direction, gonna be the difference between their speeds. What we will do? We will do Q minus P. Okay. Relative speed. Relative speed equals to speed of Q minus speed of P. So what will the speeds? I'll just have it in equation form. Okay. I'll just have it in equation form. We can solve this. First, like, solve 1000 by 12 and find the speed of Q, because we have the data for Q. We have, we know the time. Okay. So find it. Find the speed of Q. 1000 meter we are going to take as just 1 kilometer. .33 meter minutes. Okay, this is the speed of Q. Now, write the speed down here. 83.33 minus 1000 divided by x minus 1000 divided by x. This is my relative speed. Okay. Now,
Ma'am, why are we finding the relative speed again?
why we have to find out the relative speed? Because we don't have the direct data, so we cannot do it directly. We have to use the relative speed, Abraham. With that only we are going to solve it. Because we don't have any data about p.
Ma'am,
Okay. We don't.
speed difference between both, right?
Yes, relative speed is the difference between both when both are going in the same direction. Okay, so relative speed gonna be 83.33 minus 1000 divided by x. Okay, now we are just going to keep this in equation form only. Okay, now for q to cross p, the relative speed of q to p should be positive. Okay, the relative speed of q to p should be positive, means that q speed should be greater than p, but we don't know like p speed or time to cover 1 kilometer, so we cannot directly calculate the time it takes q to cross p. Okay, so we'll calculate the time taken for q to cross p. If p speed is known, we're going to assume, okay, that the distance that the distance p covers from distance that p covers from the point q starts running, from the point q starts running times p. Okay, and we're noting distance as d meter. Now, the time taken by p to cover d meters will be time taken by p to cover d meter will be d distance divided by 1000 divided by x, distance upon speed, that is 1000 by. So is the speed of p 1000 by x here above. What is the distance? We've assumed that this distance distance of p is d, and what's the time equation that we're setting up? Time equals to distance upon speed, distance d, divided by 1000 divided by x, which is speed. 1000 by x is the speed. Okay, now this becomes reciprocal happens. Okay, so it becomes dx by 1000. Okay, because it is in divide below, I just taught you all that if we have fraction in divide, we have to find out like we have to solve. If you have a fraction which is in divide, we solve it by reciprocating it and bringing it into multiplication, and then it is multiplied. So that is why x goes up and dx divided by 1000. Okay, dx divided by 1000. Now, time taken by q to cover d plus 1000 meters is 83.33 minutes. Okay, 83.33 minutes. So for q to cross p, we have to set up an equation that shows that these times should be equal. Okay, these times should be equal. So what we are going to do is that we are going to write dx by 1000, that is px, equal to d plus 1000 divided by speed. Okay? Distance upon speed. Both are distance upon speed. Okay. But the first one, we know how we obtained dx by 1000. The second one, why d plus 1000? D is the distance. Okay. Q starts running when P has already covered 1 kilometer. 1 kilometer, how many meters? That conversion, we are going to write 1000 here in meters divided by Q speed. What was Q speed that we calculated before? 83.33 meter minute. Okay, that was Q speed. Okay, so we are assuming that we need to find the time taken for Q to cover the 1 kilometer lead of P. So Q speed is greater than P speed. Okay, because P is starting fast, Q is starting later. So we are assuming that Q is faster, or Q speed is faster than like P speed. If P takes more than 12 minutes to cover 1 kilometer, Q will catch up. Okay, Q will catch up. So we assume that. Are you like understanding? We have to assume a lot of things in this question. Okay, we have to make a lot of assumptions in this question because we are not having the values that we can just directly put and find it out. Okay, so I have to think, make an assumption, and then put it in the equations. Is it clear till this point? So I'll explain it to you further. Is it clear till here?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so Abraham, say we denoted that the distance P covers from the point Q starts running, okay, is d meters. Okay, the time taken by P to cover d meters is dx by 1000 because time is what? Distance upon speed. Distance we denoted as d and speed is here. Up, I've calculated, made an equation 1000 by x. Then x came up and became dx by 1000. Now, that is done. Okay. Now, time taken by q to cover. Time taken by q to cover d plus 1000 meters. Okay, d is the distance to cover that like p is gonna cover, and that 1 kilometer extra. Okay, that this Q has to go that B covered, okay, that B went ahead, that 1 kilometer extra, that is gonna be the distance of Q, that is D plus 1000, okay, D plus 1000 meters, okay. So to set an equation, we are going to like for Q's time. Q's distance is d plus 1000. Q's time will be d plus 1000. Distance by speed. Distance is d plus 1000 divided by speed, which is 83.33 minutes. Okay. So for Q to cross P, these times should be equal. Okay. dx by 1000 and d plus 1000 by 83.33 should be equal. Okay, because the timings problem. Remember, like in the previous question, we first made A's timing to 10, right? We made A's everything to 10, whereas it was 6, but we made it 10, okay? Because we are finding it with reference to B's timing. But here, we don't have that one timing at all, okay? But still, we have to make the timing equal. Okay, time we have to use them equal. So that is why. Now, however, without knowing the value of x, we cannot solve for d. Okay, because we don't know what is x here. Okay, that is the time. X is what? The time, like the minutes it will take for p to cover. Okay. So what will we do? We will assume that we need to find the time taken for Q to cover the 1 kilometer of P. Okay, and that Q's speed is greater than P. Okay, why? Because Q started later and P started first. Okay, so because Q was fast, he started later. He was faster than P, he started later. Okay, so now if P takes more than 12 minutes to cover 1 kilometer, Q will catch up. Okay, imagine if P takes more than 12 kilometers, okay, and after 12, Q starts running. So if P takes more than 12, in that time, Q starts running and Q will catch up after 12, at a time that is after 12 minutes. At a time that is after 12 minutes. Okay, see, think about it. Think about it. P is like,
Ma'am, for Q to catch up, P has to be slower than Q.
yes, P is slower than Q, 100%. P is slower than Q, and Q has to catch up.
Ma'am, but if Q is faster than P, if P is faster than Q, ma'am, then Q cannot catch up.
Yes, then Q cannot catch up, but Q is faster. Why we know this is because Q started late. If Q would be slower, then he would have started fast and P would have started late. Right? Who starts late? Q started late because Q is much faster. So they let P start fast. Okay, and then Q started later. Okay. Now, because Q is faster and P, like 1 kilometer, P has run, that is in 12 minutes. After this 1 kilometer, Q starts. So the time that's gonna take will be the time that's gonna take P when Q will cross him, okay, is gonna be more than 12 minutes. Understanding it? How? How it's gonna be more than 12 minutes? Abraham, did you understand why more than 12 minutes? Because Q started when he has already done 12. Okay. Then when till Q catches up, P is gonna be more, like 13, 14, or 15 kilometers. Okay, when Q catches up, because Q is faster. Q is faster. Okay. So we assume that suppose P is at 15 kilometer. Okay. Suppose P is at 15 minutes. It's taking P. Okay. So what will be the speed of P? The speed of P. Now you can put 15, try 15 in the place of X. 1000 by 15. 1000 by 15. It's gonna give us 16.66 kilometers. 16.66 or 16.67.
Ma'am, why are we trying?
Yes, Abraham.
Why are we trying 15?
Why are we trying 15? 15 is just an assumption, Abraham. Okay? 15 is just an assumption. Okay? Where we have like no logic, but only an assumption, because we can put only an assumption in this question to find out. Else we don't have any data that is necessary to solve it. Check the answer of this question. Are you all getting the 16? Are you all getting 60?
In 7.67 questions are saying 7 minutes 12 seconds.
They're saying
For the
7
answer.
minutes 12. Okay. 7 minutes, 12 seconds. Okay.
Ma'am,
Um,
I don't think the question was asked to be solved. I think they had made a mistake, or a printing error must have occurred, and they didn't put the other information because
mhm.
us to do the algebra and everything, they would have put more. They would have shown a sample question.
Might be the case. But like if you go on with the method that I tried out, I didn't check the answer key, but like speed of P we've assumed 15, okay, and then 16.67 kilometer we have. Sorry, meter. 16.67 meter we have. Now time taken for Q to cover 1 kilometer lead. Time taken for Q to cover 1 kilometer lead, we are going to divide 1000 by 16.67. That is the speed of T that we've
Ma'am,
calculated. Yes.
my brother has a class. It was supposed to start at 9 o'clock. So can I please log?
Okay. Yes, you can log out. Yes, Abraham.
Ma'am, could I take 20?
Can you take 20? Take 20 and try. Okay. Take 20 and try. That's fine. Okay. So this is the
Ma'am,
yes.
can I log out?
Yes, you can. See you tomorrow. Bye.
Bye, ma'am. Thank
So, ma'am, my question is, so why did you do the distance taken by P to cover by meter? Ma'am, why did you add D?
Why did I add what, Abraham?
Why did you do the entire equation of time taken by P to cover D meter?
Okay, this D meter.
Ma'am,
This D meter was to like show you that the time is going to be like we have to balance the time. Okay, like in the previous question, the 10 thing was there, right?
so entire equation was just to show us that P's time should be more than Q.
That P's time should be more than Q. And Q speed will be more than P. Q speed is going to be more than P, and P's time is going to be more than Q.
Ma'am,
Hello?
when I'm solving the question and I already know this, can I just write if I have to solve another question like this, can I just write P speed is more than Q instead of writing Y?
Yes, Abraham, you can do that. Okay, you can do that. Yes, Anna, you can leave too. We've just ended. Okay, and I like try to like when I tried it, this was like the solution I could do because we had to assume the values. Okay, because we didn't had any values. But I'll still try it and another time, one more time I'll try and see if like I can come up with solution or something, or like if you have to only assume the values.
And we could take 1000 by X minutes. 1000 by X minutes.
1000 by x minutes we've taken, yes.
No, instead of simplifying it further, because there is no further simplification into
Hmm.
60 minutes, we could keep it as a expression saying 1000 by X minutes, and we could give that as the answer.
Give that as the answer. Not
I'm
really,
assuming.
Abraham,
So,
because
ma'am,
hmm,
because we don't know the speed of P, what will we do? What we do is then we have to take 1000
yes,
by
we don't.
X, and then we just have to
Okay, Anna. Okay. So, but still, like, we do not leave it like that. That would be quite incomplete. So, I suggest you solve it with this method. Okay. I'll also try to redo it and see if I can come up with another method. Okay. But, like, the problem is the information that we're not having. But I'll still try. Okay. And we'll, like, move forward. Tomorrow, I'll do the length of the train, right? Or the speed? Speed of the train, I guess. Abraham.
Yes, ma'am. Speed of the train.
Speed of the train. Tomorrow we'll check out speed of the train. And that's all for today. Okay. See you all tomorrow.
Okay, ma'am.
Bye, ma'am. Thank you.
Bye. Bye.
Bye.